Yes, featuring astronomy thought leaders in the field of space infrastructure development. Our next speaker is Emma Lehnhardt. Am I saying that correctly, Emma?
Yes, you got it. First try.
Excellent. Great. And I can hear you loud and clear. Thank you so
Great.
much. Emma Lehnhardt is the Planning and Control Manager for the Gateway program at the NASA Johnson Space Center. She leads the team responsible for business operations of the Gateway, which will be an outpost orbiting the moon to provide support for sustainable long-term human return to the lunar surface and a staging point for deep space exploration. It is a critical component of NASA's Artemis program and will help prepare us to send the first humans to Mars in the coming years. Emma has also worked at the White House's Office of Management and Budget and Space Policy Institute and consulted for government agencies and aerospace companies. She holds a master's in international science and technology policy from the George Washington University and a BA in politics and astronomy from Mount Holyoke College. Please join me in welcoming Emma Lehnhardt to Blue Marble Week.
Thank you very much, and nice to meet you virtually. Yeah, I just saw a peace sign from Michael. Michael, thank you very much for the invitation here to join this forum. Michael and I were actually students together at the International Space University, where we met, Michael, I believe 12 years ago now. Yeah, I know. So, all right. So I just have a few slides and high level discussion of NASA's deep space exploration plans, the Artemis program, and how my program, Gateway, fits into that. So I will go ahead and start sharing my screen here. I am not a Zoom expert, by the way. The US government doesn't use Zoom very much. So let's see. Perfect. So thank you very much for the lovely introduction. I'd like to start with a quick caveat about myself and my background. So the program planning and control, PP&C as a discipline, really can be described as the business management side of management of a program. So I am not an engineer. I am not a scientist. I'm assuming there will be some questions along those lines, and I will do the best I can. But I'm much more on the business and dollars and side of the house here. So this is an interesting week for me. We have a continuing resolution funding the government right now that is expiring at the end of this week. So this is a very, very interesting time, as it always is. So with that, I can jump into a quick discussion of the NASA Artemis program. Artemis is a construct of multiple different human spaceflight programs, the Orion capsule, Space Launch System, Exploration Ground Systems, as well as Gateway and the Human Landing System, and science missions and technology demonstrations across NASA. And it is named Artemis very fittingly because Artemis was the twin sister in Greek mythology of Apollo. And this is our return to the moon after Apollo into cislunar space and setting the stage for going beyond the moon into deeper space and in particular aiming towards Mars as the horizon goal for our human space exploration plans. A key focus area of Artemis is returning humans to the surface of the moon. I am sure you have heard this, the first American woman and the next American man to the surface of the moon by 2024. We are very, very interested in the moon's south pole, an area of interest for science in particular and future resources utilization. I inserted a link here on the right-hand side of the slide to a video called How We Are Going, which I won't bring that up today, but if you have a chance to check that out on YouTube, I think it is a fantastic explanation of the overarching Artemis concept and what NASA's plans are with our commercial international partners going forward. It is also narrated by Kelly Marie Tran from Star Wars. So very, very cool. As we pursue the Artemis plans, and in particular, returning humans to the surface of the moon, we are pursuing a phased implementation, both going around the moon with the first missions of the Space Launch System and the Orion capsule with crew, deploying the Gateway in lunar orbit, which I will go into then in more detail later, and deploying surface assets, including robotic landers, robotic rovers, and then the human landing systems. This phased approach, it takes a whole agency perspective to accomplish. We are working across all of NASA's mission directorates, and as I mentioned, with our commercial and international partners. I work for the Gateway program. I manage the budget and the resources for Gateway. My bosses are the program manager and deputy program manager for the Gateway program. We are located at the Johnson Space Center in Houston, Texas, but we have participation across the program with our projects at basically every NASA center across the country. What we are doing is building this Gateway, a cislunar outpost, a platform in orbit around the moon that will really serve as the building blocks for our future plans. Being able to aggregate the Orion capsule with crew and the human landing system at the Gateway for services down to the moon, as well as be a launching pad, so to speak, for the buildup of future capabilities that we need going into deep space in the future. On the screen right now, you see an artist's rendition of the early phases of Gateway. The first two pieces are the power and propulsion element, as well as the halo, the habitation and logistics outpost, which provides the first living quarters for the crew on Gateway. Don't know if you can see my cursor, but off to the left-hand side of the graphic, this is an artist's depiction of what the human landing system could look like. And off to the right-hand side is a depiction of a logistics module coming to the Gateway and docking. So as you can see, there are multiple docking ports that allow for an incremental buildup at the Gateway. And I'll go into a quick status of the development of each of these pieces for the Gateway and our partners on the next couple of slides. But before I get there, I did have a slide in here about the Gateway's orbit. And Michael, I did join the conference a couple minutes early and got to hear a little bit of the last presentation. Did you guys go into this particular orbit, NRHO, the near rectilinear halo orbit? No. Okay. So this is a very specific orbit. The concept of a Gateway in orbit around the moon has been in architectural trade space for a very, very long time, decades. And we had looked at several different types of orbits for the Gateway, low lunar, distant retrograde, and the NRHO provides many, many benefits, and this is where the Gateway will be operating. It gets very close to the lunar surface, about 1,500 kilometers at its closest and out to 70,000 at its farthest. It provides a true deep space environment for science investigations and thinking about the deep space environment and how it impacts our crew in the future, for example. It is accessible by launch vehicles on the market today. It provides a really good communications perspective back to the Earth. And for Blue Marble Week, a continual viewing presence of the Earth, of the full blue marble, yep. And will allow us to access a variety of different places on the surface of the moon that we had not been able to before. All of the Apollo missions really landed in the equatorial region of the moon, and this will allow us to move around and go to many other places on the surface of the moon, in particular that lunar south pole of such scientific interest. So our first components, I briefly mentioned this, the first two pieces of the Gateway that we will be launching are the power and propulsion element. It's a 60 kilowatt class spacecraft providing solar electric propulsion, and will provide the rest of the Gateway stack, the integrated spacecraft, with electrical power, propulsion, and communication capabilities. It is under contract right now with Maxar Technologies, and they will be providing that element, the PPE, power propulsion element, to be launched together now with the habitation and logistics outpost HALO. Previously, we had been planning to launch these pieces individually and have them dock in orbit around the moon, but we will now be able to launch them as an integrated spacecraft. HALO is under contract with Northrop Grumman and will provide that initial living quarters for our crew, multiple docking ports, 3 of them, one on the, you can see right here on the screen, and 2 on the side, as well as cargo space, and both of these spacecraft provide accommodations for science and technology payloads. The first 2 science payloads have already been selected for the Gateway to fly on PPE and HALO when they launch. Both have to do with investigating the deep space environment. And one is being provided by NASA and another by the European Space Agency, ESA. Another critical piece of the Gateway is providing the ability to resupply and fly logistics, consumables, things that we need to conduct missions both on the Gateway and on the surface. And we are under contract with SpaceX for a contract called the Gateway Logistics Services, managed by our Deep Space Logistics team at the Kennedy Space Center. And this will be to fly logistics modules up to the Gateway, and they can carry 5 metric tons of cargo, as well as pressurized and unpressurized capabilities. Okay. These are services that are designed quite a bit on the lessons that we have learned in NASA from the Commercial Crew Program and the Commercial Resupply Services. So this is a full services contract of delivery of critical cargo that the crew will need. Another major piece that we will need for these missions going forward are future spacesuits and capabilities for extravehicular activity, EVAs. We call this Exploration EVA or XEVA, and this is a full project that is building the future spacesuits, as well as all of the tools and the interfaces with vehicles like the Gateway or the Human Landing System provider vehicles that are needed for future EVAs and suits, both on the International Space Station, on the Gateway, and on the surface of the moon. Honestly, we could spend an entire day talking about all of the coolness that is being pursued by these folks. They're really fun to listen to, and everything that they are doing with these suits to allow so much more mobility and ability to conduct EVAs in the future than what we had during Apollo on the surface of the moon. One of the really key elements of the Gateway program is that this is a true international partnership. The future pieces of the Gateway are envisioned to be provided by our international partners. You can see them listed below. We are working with the Canadian Space Agency, the European Space Agency, JAXA, the Japanese Aerospace Exploration Agency, as well as some preliminary work with Roscosmos in Russia. We have a memorandum of understanding signed with the European Space Agency. That was a piece of news that came out just a little while ago. And Canada was one of the first partners to really publicly step up as part of the Gateway. And just yesterday, they announced that they had released their first contract for the robotic arm, Canadarm3, to MDA. So that's very exciting news. Yep. So Europe will be providing another habitation module. We call it the IHAB, International Habitat, as well as something called the Esprit that will provide the ability to refuel the spacecraft. So this is the full configuration on the screen now. in the future when we have all these pieces coming together. We're very, very excited for this. It's hard for me to express properly how incredible this is to be a part of this. And we're very, very excited for the future. And that is all I had, Michael. I wanted to leave plenty of time for questions.
Terrific. Thank you. Thank you very much, Emma. You mentioned the ISU connection. We went to school in Barcelona 12 years ago. It was great. Did you imagine, fast forward 12 years ago, we'd be talking about the first woman on the moon, the next man, building an entire system to support all the pieces that go into that kind of work? Like, where were you, kind of career-wise, imagination-wise? Where were you?
That's a great question, Michael. So when I started my graduate degree at the George Washington University, the Space Policy Institute.
Space policy, right?
Yep.
Yeah.
Mm-hmm, yep. We were still pursuing the vision for space exploration under the Bush administration, and so that was really my first architecture, my first plan that I lived and breathed, and it honestly just personally made a lot of sense to me. Moon, Mars, and beyond, and now we're kind of back in that place, and I didn't foresee that absolutely when we were at ISU, but I'm glad we're here now. Yeah.
So the whole set of events yesterday, day before, the stuff that we've got planned coming up the course of the next year, it's all about infrastructure.
Mm-hmm.
It's all about the here and the now. It's all preparatory for the soon. Our industry has taken a lot of heat for the science fiction of our ideals, and how far-fetched they are sometimes. But you're doing the actual, I will say, budgeting of building the future, right? That's basically your role.
Yeah, that's a great way to say it. Mm-hmm.
All right. So it's not science fiction. You work with the spreadsheets and the Gantt charts and all of that every day to build out that future. So not science fiction. Is that safe? Right?
Not science fiction.
Right.
If it didn't come across clearly, we are under contract for these pieces. We
Right?
are spending money. This is, our partners are as well. And it's real.
Good. I'm very happy to hear that.
Yeah.
I know that, but I just really want it said loud and loud. And clear.
Yes.
We know that we've got international partners.
Yep.
The Artemis Accords have been signed by, I think, 8 partners now. Is that 8?
Oh, I thought we were up to 10, but
okay.
yeah.
You probably know this better than me, so that's why you're here. So 10 partners. We've got 14 or 15 on the International Space Station. What kind of partnerships are we looking at for Artemis? What do we have currently? What would we like to have? A lot of this conversation the last couple of days have been about gap closing. So what are our gaps and how do we close them?
Yeah, really good question. So the Artemis Accords really establish kind of overarching governing principles.
Mm-hmm.
I mentioned MOUs. So for the Gateway in particular, we legally are expanding the International Space Station Intergovernmental Agreement, IGA, with MOUs that build on those partnerships.
And
so
those are treaty level documents, right?
Correct.
State Department level documents.
State Department. Yep. So this has been basically a 2-year effort getting these MOUs assigned and through all the intergovernmental processes. They are the rock solid agreements in between the U.S. government and these other space agencies for the partnership on Gateway. And those are applicable to our current international partners. That's who we are working on with those. But what I would say is we also have international interoperability standards that we are building the gateway using. So docking systems, for example, will all be built with an agreed set of interoperability standards. So that allows, in my view, for lots of different possibilities in the future for partnerships.
So what kind of partnerships are you looking for, both governmentally, and I don't think you can answer this question, so bow out if you need to, but commercially?
Well, I mean, I would say that our contracts that we have right now are partnerships,
Right.
Particularly since we are pursuing the use of firm fixed price contracts for the pieces of the gateway that we have under contract today, which require some risk buy-in from our commercial partners. Absolutely. Right. Mm-hmm.
Okay. Will this look like, I've seen these are not my words. These are public media words, and I'd like to very clearly say I don't agree. But there's been talk about Apollo on steroids. There's been talk about is this an ISS style? It's kind of a blur between those, right? So what are we looking at in terms of what we're going to land? Who's going to go with us? How is that going to look?
That was, I think, a couple different questions in one there.
Yeah, sorry. I
no worries. I think of Gateway as a critical piece of Artemis as not just ISS 2.0. That's certainly not it in terms of the size of the station or the way we are pursuing our commercial and international partnerships. We absolutely have leveraged lessons learned from other programs, in particular the Commercial Crew Program. So I think it's a blend, like you said. It's a blend of everything that we have learned on ISS and with Commercial Crew, and incorporating key lessons from Apollo. Absolutely. I'm not going to touch on the human landing system. I will say that I am not an expert and probably can't speak to that very, very knowledgeably. Mm-hmm.
Okay. Major Sean McLean just gave you a shout out. It's Gateway is the first step.
Yes.
So
Yep.
So support from Major McLean there.
Thank you.
He would actually like to keep a conversation going, so he's proposed his email. So I want to make sure that you saw that.
Perfect.
He's going to go by Major McLean. Thank you. When there's a question from the audience, I don't agree, they don't agree, but I'm going to say it anyway. Direct to Mars people have said that Gateway is a high cost, long-term, time sink. Certainly I don't believe that, but what's the counter argument to that?
I think this gets back to the conversation that you were having at the end of Major McLean's presentation about infrastructure and step by step building.
Right.
We believe that the gateway is essential for lunar exploration, but also for the buildup of capabilities and demonstrating the technologies that will keep people safe when we do go to Mars. Is it high cost? So if you're building an outpost in orbit around the moon, it is going to require some money. Yes. Is it high cost in comparison to other major programs that of record? I would say we are absolutely pursuing this because of its affordability aspect.
Right. So I'm gonna push that a little bit. We've got 3 commercial providers that are in the running for landing hardware up there. Bryce issued a report about 2 months ago talking about something north of 70 missions to the moon. Our international partners have got something like 20 some missions over the next 10 years. These are projected missions over the next 10 years. would this even be possible financially? Would it be possible to do this ambition a role without really, aggressive work from our supplier network, our commercial providers?
The industrial base is diverse and strong, and that does need to be there to support all of these international missions that you've mentioned to the surface of the moon, as well as the smaller and larger missions that NASA is planning. Beyond the three major competitors for the human landing system, we also have a commercial lunar payload services CLIPS program that will be, yep. So, and that's working with.
I know what CLIPS is. Tell what CLIPS is.
Yeah. Okay. So it's a procurement mechanism that is partnering with. What I'm trying to come up with the right word here, Michael. A lot of non-traditional aerospace companies who will be able to land smaller payloads on the surface of the moon. So that's a way to really expand the supplier base, the industrial based strength. Mm-hmm.
I want to point out that we've got a representative from the Washington Aerospace Futures Alliance and Washington State Space Coalition. They're very interested in what does this financial industrial based ecosystem look like. So it's really important that be a component for this industrial base that we're building, this potential that we're trying to build. It's going to rely on quote unquote good old fashioned American know-how, right? So
and suppliers from everywhere. Absolutely.
Everywhere.
Mm-hmm.
And they've got time now.
Yeah.
Say again?
They've got time.
Yeah.
Time, capacity, capability, people hardware, software. Yeah, it's engineering to CNC machining to everything. They're ready. That's what I was just going to ask about. If there's a way to connect with CLIPS and make some connections.
Yeah. Aaron, I'll connect you in with some of that stuff. That's why you're on this call. Thanks for being here. All right. We're going to move over to our next topic in just a moment. Emma, can you post in the chat how people can connect with you? And I'm going to ask you just one aspirational question, right? You've been at this for a while. You're literally in the middle of doing it right now. As soon as you quit this call, you're going right back to building our roadmap to the future. What do you, speaking as an individual and not as a NASA employee,
yes,
what do you want? Say 2022, 2025, 2035. That's the end of our time capsule here. What do you want?
I want to see a dynamic cislunar environment or ecosystem. I want to see lots of activity from lots of different people. I want to know the crew who is flying in orbit around the moon, and I want to be able to go outside in Houston, Texas, and look up at the moon and say, I know who's up there right now. Yeah.
Awesome. Thank you so much, Emma. Really appreciate your time. Please post your contact info if you're willing.
I will.
And we're going to switch it back to Lila. Thanks a lot, Emma. Appreciate it.
Thank you.
Bye-bye.
Bye-bye.
Thank you, Emma. That was great.